Hi students, today we will discuss about a numerical problem of finding V and I in the circuit shown in the figure below using nodal analysis. So see here, V means voltage drop across the 3 ohms and I means current in the 2 ohm resistor. Uh, in the earlier videos we already discussed about the numerical problems belongs to the circuits which consists of only independent current sources, and later after those concepts, both the independent and dependent current sources, after then independent voltage source between non-reference node and reference nodes. Now this concept, this numerical problem belongs to them. What happened when independent voltage source between two non-reference nodes, okay, in addition to the non-reference node and reference nodes. See, observe here, in this circuit diagram the voltage sources are there. So before going to discuss about this, first of all we will identify where are the nodes are there here. So first of all we will consider, see, the junction of two or more branches is nothing but a node, or elements is nothing but a node. So that's why this I consider it as a, this is a one node, and here the junction of 3 volts is also one more node, and here this is another node. Okay, so now there is no element is here, so this same node I considered here. Now all these 7 volts, 3 ohms, 2 ohms, 6 ohms are commonly connected at this point, so that's why I consider this is a one node. So that's why here I consider this as a reference node, so which I assigned as a 0 volts for this, and here these are non-reference nodes. So here V1 I consider this as a voltage, assign the voltage at this node, and V2 is assigned at this node, second node, and V3 is assigned at the third node. Okay, now what is the difference between this problem and this earlier problem? Means here the voltage source is given in the nodal analysis. So voltage source, where it is located between non-reference node and a reference node, and one more voltage source is connected between two non-reference nodes. So if you want to do this problem, you need to apply a new concept we will discuss. Okay, so here by seeing the node, by seeing the circuit itself, we can easily identify what is the V1 value. So here the V1 value is nothing but the voltage of this point with respect to the reference node. So that's why here in between these two nodes a 7 volts is connected. So that's why plus polarity is connected to the V1, which is a non-reference node, minus polarity is connected to the reference node. So that's why here the voltage at this non-reference node, that is V1, is plus 7 volts. Okay, so directly it is given. So that's why by seeing the circuit itself we can easily identify what is the V1 value. V1 value is 7 volts. Okay, now coming to this one. Here this 3 volts is connected between two non-reference nodes. So here it is a plus terminal is connected to V3 and minus terminal is connected to V2. Here you, by applying the nodal analysis, you need to find out the current values, but here there is no resistance is there. So that's why you cannot directly apply this nodal analysis concept to this problem. Okay, so first of all you have to identify where the voltage source is connected between two non-reference. So that's why here we identified this is a, here we consider. So that's why wherever the voltage source is connected between two non-reference node, we consider this node as a super node. super node. Okay, so that's why while dealing with this type of problems, so you have to consider wherever be the voltage source is connected between two non-reference node, that node we can replace it as a super node. So that's why now again if we redraw the circuit diagram, so here this is a 4 ohms and here is 3 ohms. Is enough. Next one, here it is 2 ohms. Okay, now this is 6 ohms. Okay, and here already we come across 7 volts. Okay, so this is about this. Now we consider this super node, that is this 3 volts is eliminated here. Now here it is V2 and this is V3 and this is V1. Okay, now we will I missed here, this is a 2 ohms and this is 6 ohms. Now we write the KCL, that is applying the this super node concept. We are going to write the KCL for this node. Okay, that means that for this entire super node we consider it as a one node itself by removing this 3 volts. So now write the KCL for this one. So now for this super node apply KCL at super node. So what is the current here? Here for this V2 minus V1, that is potential difference in this branch. V2 minus V1 divided by 4. V2 minus V1 divided by 4. Next one. This is a 3 ohms branch is connected. Next. V2 minus 0. Why means this is a reference node. For reference node it is 0 volts. So that's why V2 minus potential difference is V2 minus 0 divided by 3. Next. Here this entire super node V3 is also considered here. So that's why V3 minus 0 in this 2 ohm resistor. V3 minus 0 divided by 2. Next, in the 6 ohm, V3 minus 0 divided by 6. So this entire super node we consider it as a one node. So that's why I written current in the 4 ohm resistor, current in the 3 ohm, and current in the 2 ohm also, current in the 6 ohm also. The sum of all these currents at this node, at this super node is 0. That is the KCL. So now by applying the this LCM, we got 12 is the LCM. Okay, now this is 3 into V2 minus V1 plus 4 into V2 plus 6 into V3 plus 2 into V3 is equal to 0. So now we got 3V minus 3V1 plus directly I am solving. 3V2 plus 4V2 is 7V2 plus 6V3 plus 2V3 8V3, which is equal to 0. So now I considered this equation is the first equation for this super node. Okay, so now by here at the first the voltage between this non-reference node and reference node, it is already given 7 volts, that is V1 value as 7. So that's why now I am substituting this V1 value here. So now minus 3 into 7 plus 7V2 plus 8V3, which is equal to 0. So that's why 7V2 plus 8V3 equal to, this is a 21, this minus 21 if you send here, plus 21. So now this is your first equation. Okay. So like this, if we combine this one, this for this entire supernode, you are writing only one equation. Next, now only here we written the KCL for this supernode. Now whatever be the eliminated branch, this is 3 volts is eliminated branch. Now I redraw the circuit with that eliminated branch and remove the elements which I already written the KCL. Okay, so that's why now redraw the circuit diagram. Now I will draw only the eliminated branch in the supernode. So that's why here this is a node number 2 V2, and here is your 3 volts source. This is the eliminated one. So this is V3. Okay, so the remaining this is a minus terminal and this is plus terminal, this is 3 volts. Now the remaining elements I will redraw with the dotted line, because I don't need this one, so that's why I directly draw the dotted lines. Okay, clear? So now this is I am going to apply now. For this eliminated branch I redraw the circuit. So now what about this eliminated branch voltage? So here you observe here only two nodes are there. In between these two non-reference nodes 3 volts is there. So where is the plus terminal is connected? V3. Where is the negative terminal is connected? V2. So that's why the potential of V3 with respect to this V2, that is the difference between these two terminal voltages is 3 volts. So whether it is V2 minus V3 or V3 minus V2, V3 is connected to the plus terminal, so and negative terminal is connected to V2. So that's why V3 minus V2, which is equal to 3 volts. Okay, 3. So this is your second equation. Okay, now by solving this first equation, this is the first equation, and this is the second equation. Okay, by solving these two equations, we got the V1 as V2 value as minus 1 by 5. Minus 1 by 5 is equal to minus 0.2 volts, and V3 value as 14 by 5. Okay, volts. Now what is the question they asked? What is the find V and I in the circuit? So that's why no doubt the V is nothing but plus terminal is connected to V2 terminal, so that's why V2 node, so that's why small v is equal to V2 voltage itself. So that's why small v is equal to V2, which is equal to minus 0.2 volts. What about I? Here one more question, I is there, so that's why where is the current I? I is the current in the 2 ohm resistor. So what is this current I? The current I is nothing but potential difference divided by the resistance. So where is this I is passing here? So in between the nodes V3 and reference node. So that's why what is the I formula? I is equal to V3 minus 0 divided by what is this resistance value? 2. So that's why, so what is this value? 14 by 5 minus 0 divided by 2, so you got 14 by 5 into 2, so which is 1.4 volts, 1.4 amperes. So this is the way we are going to find out the voltage V and I by applying the nodal analysis. Okay, thank you.